I'd like to show you how to apply feedback to a voltage amplifier. That's an amplifier with voltage input and a voltage output. Here we have an amplifier A, has a gain of A, that has voltage input and voltage output. We'd like to apply feedback by measuring a little bit of the voltage output and multiplying it by beta to give a feedback voltage V sub F, which is subtracted from the new input voltage V sub S to give the old input voltage V sub I. Notice that V sub I equals V sub F S minus V sub F, and V sub F equals beta V out. Let's see what we can do, starting with an op-amp circuit, to affect this kind of feedback. We're going to start at the input here. Vi equals Vs minus Vf. Here we have an op-amp. The input voltage to this op-amp is this voltage right here. So it's Vi. This is the output voltage to the op-amp, so it's V out. And now what we have to do is we have to make it so that Vi is equal to Vs minus Vf, which means that this top terminal right here has to be at Vs, and the bottom terminal has to be at Vf with some reference. I'm going to use a ground reference. Let me just draw that in here. The top needs to be at Vs, so this source is Vs. And the bottom needs to be at Vf. So this voltage right here, with reference on ground, has to be Vf. Now we've effectively satisfied this first equation right here. Now I'd like to concentrate on the second equation right here. We need to make the Vf voltage proportional to V out. And the beta network needs to be a smaller number than 1, because the gain of the overall circuit is approximately 1 over beta. So generally we'd like a gain greater than 1 for the overall circuit with feedback, so that means beta has a gain less than 1. So we need to make a circuit here that samples V out, which would have some kind of a load resistor on it, probably like this. Where V out is the voltage across that load resistor. So we need to sample that voltage, and the way to do that is in parallel. When you measure a voltage, you have to connect your meter on in parallel. And essentially, this network that we've just made here is sampling the voltage right there, so it needs to connect on to there. Let me make this bottom resistor R2 or R1 and the top one R2. Then we can take the voltage right here and connect it over to Vf right there, so that Vf equals R1 over R1 plus R2 times V out. And that gives us exactly what we need, with this quantity right here being beta. And of course the gain on the op-amp, it was A, so you could put that in there as well. We've essentially affected in a circuit what we had up above as a block diagram. So that's how you go from a voltage amplifier block diagram to an actual voltage amplifier. This is called series voltage feedback. The reason it's called series is because they call this this input right here series mixing, and they call the output voltage because it is voltage. So it's voltage sampling, series mixing, and that's why they call this a series voltage feedback. It's the kind you need to use when you have voltage on the input and voltage on the output.